Hey everybody. Today, you can see the title on the screen. What we're going to do is we're going to go through a process in order to change the form of our quadratic functions. So within this unit, we've been working our way through dealing with parabolas. We've talked very specifically about graphing or sketching those parabolas. As well, we've talked a little bit about some of the features of them. What I want to do today is I want to introduce two different forms for our quadratic function. I want to talk a little bit about the benefits of both, and then I want to spend our time today going through changing to vertex form. So, for us to get an idea of the title, I think we need to break down two very important forms. Okay, let's jump in. I'm going to give you a moment just to take a look at the screen in front of you. What I've done is I've put down two very common forms of quadratic functions. Now, I want to highlight, just as we get going, you'll notice kind of almost like two columns, one in red and then the other in green. I do want to just highlight my highest power on my x is a 2, so you notice that red is a quadratic function. You will also recognize in the green form, that exponent 2, there is my vertex form of my quadratic function. So just before we nail down the particulars of each form, I just want to highlight they are both quadratic. Okay, I'd like to get rid of those blue highlights, and now I'd like to focus in on the red for a moment. When we break down the standard form of a quadratic function, what you'll see is what we have in red. This is going to look very familiar to you because we've already addressed how to solve quadratic equations. So the fact that we have an ax squared plus bx plus c should look very common. If we had had any brackets, if we had had any other operations, standard form is when everything is expanded and everything is collected and written in descending order. Now, what is standard form useful for? Well, you'll notice what I put in gold. We can still see the lead coefficient on our x squared, and we denote that with an a. That's going to represent the shape of my parabola. So we should be good that could end up being a steeper parabola, a flatter parabola, or our normal shape. The other part that we may not be familiar with is my c value on the end would represent my y-intercept. I do not have to do any calculations to find my y-intercept when I'm dealing with standard form because it's just the constant. Now, if you're looking at that and you're saying, yeah, but why? I want us to take a moment to calculate or find our y-intercept. If I had asked you to find the y-intercept of that parabola, I hope you would be good that to find your y-intercept means your x value equals 0. Now, I'm not going to actually sub in 0. I want you to look back up at the red standard form equation. And notice, if I were to sub in x equals 0, that is going to wipe out that first term. Because now I have 0 squared, which is 0, times a, which is 0. You'll also notice that it's going to wipe out my middle term. Because whatever my b is, I'm about to multiply it by 0, so I get 0. So that whole thing just finishes off with c. So I'm hoping we can understand now why I can just read my y-intercept from my standard form. Okay, I want to transition and take a look at my green form. To put a name to what we've been working with for the last while, that is my vertex form. Why do we call it your vertex form? Because you can read your vertex from that form, and you'll notice there is my vertex at h and k. You'll also notice that you can tell the shape of your parabola from that form. So that's also useful. Okay, I would argue to you vertex form may be more important just because it allows us to read the most important point of that parabola, its change of direction, its vertex. However, each of those versions give us different information. Sometimes one is more useful than the other. These are our two main forms for our quadratic functions. What I want to do now is I want to go and change from one form to the other. I do not think it is an issue, nor do I really think it warrants us really having a conversation about how we would change vertex to standard. Clearly, you would just expand your brackets and collect like terms. That is something that we did so much of in previous units. I don't even think we need to practice that. You should be good. Where I want to spend our time today is about taking something in standard form and trying to change into vertex. That's going to require a different process. So let's take a look at that specifically. What you see on the screen right now, there is my standard form parabola. I put it in white. That is my given form for my function. In order to turn that into vertex form, I have to change it into the blue. And what we're going to do now is we're going to go through a process to do that. Okay, this is going to get ugly. So I don't want you to get concerned if as we're working your way through this, you get lost at some times. That's okay. We're going to pattern some stuff and we're going to walk through it together. Okay, the first thing we need to recognize is that for me to write this in vertex form, I need to put a perfect square back in to my function. Now, more importantly, that perfect square has to contain my variable. Now, if you look back at my given standard form, you might say, hey, well, there is a perfect square with my variable. But the problem is, there's another term with a variable. And if you look back in my blue vertex form, you'll notice we only have one term with a variable. So I need to be able to go through and write my standard form with one variable perfect square. It's almost like I have to say to myself, I have to put the square back in. Like I have to go backwards. So how can I do that? Well, the first thing I'm going to do is I'm going to look inside my bracket and notice that my x has a coefficient of 1. Look with my orange circle. So I need to eliminate this coefficient on my x squared. Now, I can't just go and divide it out, because if I divide out that a, then I would have to divide out the a on the left side, and you'll notice I don't have y divided by a in vertex form. So the way that I can fix this is not to divide out my a, but factor it. What I'm going to do is I'm going to factor out my a from both terms that contain the variable. That's my first step. I'm getting closer because now at least I have a coefficient of 1 on my x squared. Okay, now what I need to do is I really need to factor what was inside my brackets. And I wish that what was on the inside of those brackets was a perfect square. My problem is it's not. So what I need to do now is try to get a perfect square inside my brackets. Okay, just to make sure we're good with y. If I took my vertex form and I expanded my brackets, you'll notice you would get 3 terms. And we should be good with that because we know how to factor perfect squares. We know how to expand perfect square binomials. So what I need to do is to somehow get a 3rd term inside those brackets. Okay, I'm going to put one in there. That is, I'm going to put in the value that would make the inside a perfect square. Okay, in order to do that, I think we need to pattern some things out. So we're going to kind of work in a way that's going to allow us to work backwards. To do that, I just need to slide this across. I want you to ignore the fact I'm writing this underneath the blue. This is not related to the blue. If I gave you x squared minus 8x and a blank, and I asked you, what value would you sub in that blank spot that would make that gold a perfect square? That is, what would you sub in that blank spot that would allow you to factor that into a perfect square? I want you to take a moment and try to come up with what value you think that could be. Okay, were we able to come up with that value? We were, if we were able to come up with a plus 16. Now, if you're looking at that and you're going, okay, how do we get this plus 16? Why does that work? Notice, if you factor that into an x minus 4 squared, that would expand into x squared minus 8x plus 16. That is, x minus 4 all squared would be the perfect square we need. And the only way that we can get that is by having a plus 16 on the end. Okay, let's try another one. What if I gave you x squared plus 12x? What value could you plug in on the end that would allow you to have a perfect square? Again, I want you to take a moment and try to see if you could come up with that value. Okay, I would love it if we came up with 36. Okay, how do we get 36? Well, if I had an x plus 6 all squared, then that would expand to give me an x squared plus 12x plus 36. Nice, 36 was the value that I would be looking for. Okay, maybe you can see a trick. I shouldn't even say a trick, a pattern that allows us to figure this out. I want you to take a look back up at the x squared minus 8x example. You'll notice that if this was a perfect square, then that coefficient of minus 8 has to be made up of 2 of the exact same thing. Remember, when we expand our x minus 4 squared, we square the first, multiply those together, and double it. So for me, to figure out the value that would go on the inside of the bracket, I would have to take half of my middle term. So I'm going to divide it by 2. Now that I know the value that's inside my bracket, now what I need to do is square it to get the constant. And negative 4 squared is my positive 16. Okay, I want you to notice that pattern is the same. For me to go through and figure out the value on the inside of the brackets, I have to cut that in half. Then I need to square it to get the constant on the end. Square 6 gives me 36. Okay, let's try that with one a little uglier. So what if I gave you x squared minus 5x? What value would have to go in that blank spot to make that a perfect square? Well, if we take half of the 5, then that gives you a 5 halves inside of our brackets. Yeah, that's why this one's a little uglier, because 5 doesn't divide by 2 evenly. But it doesn't stop us. We just happen to get an uglier value, a fraction. Well, now that I have that 5 halves in my bracket, now I need to square that in order to get my constant. And when I square 5 halves, I'm going to get a positive. Square the 5, square the 2, and there is the constant that would make that a perfect square. Nice. Okay, all that patterning that we just did is going to be really useful for the orange. So I'm just going to get rid of that. And we'll include it again later. But let's work our way through the orange. I'm now going to think to myself, what value would I love to have inside my bracket that would make that a perfect square? Okay, so I know that what I need to do is now take half of my coefficient on my x. Well, if I take half of b over a, I'm going to hop off to the side. Well, b over a cut in half could be viewed as b over a times 1 over 2, right? To divide fractions, I'm going to flip and multiply. I would hope we would have just been faster to say that if I'm going to divide a fraction by 2, then I need my extra factor of 2 on my denominator. I would get my b over 2a. Okay, that was part of it. Now I need to take that b over 2a and I need to square it. So look back over on my green, and what I now need to do is to take my b over 2a and square it. That means I square my top and I square my bottom. Make sure we square the 2 as well as the a, and we are good. Okay, that's a lot uglier than the examples I gave you. But that gold expression is what we need to have inside the orange brackets to make that a perfect square. So what I'm going to do then is just erase some of that extra red. And I'm going to write in gold what we needed. I need to add in a b squared over 4a squared. Now, you should look at that and say to yourself, wait a second, you can't just add in a value, you just change the value of the function. Of which I would say, well done. Yes, I can't just do what I just did. So now how do I fix it? Well, what I can do is I can subtract it right away again. I want you to take a look at what I've done because it looks like I'm pulling a trick, and I'm not really pulling a trick. If you take my gold and subtract my blue, the value I get is 0. And notice I can add 0 to an expression without changing its value. I just picked the form of 0 that was going to be most useful to me. Okay, there we go. We're getting there. We're getting there. So, I now have my a times my x squared plus b over ax. But this becomes my problem. I don't have a perfect square inside my brackets because I got that extra blue fraction. I really wish that that blue fraction was not there. Well, how do you get something out of brackets? We expand. So what I'm going to do is I'm going to take my a and I'm going to multiply that by my blue. I'm going to expand my blue term out of the brackets. Okay, I want you to take a look at my orange. My orange is going to be what doesn't change from the previous line. There was my gold fraction copied back out. But once I do the green and I multiply out that blue fraction, I'm now going to have b squared over 4a. Now, you might look at that and you might go, hey, wait a second, Gray, you forgot the squared. Can I just get you to look down in red at the bottom right? I took a and I multiplied it by b squared over 4a squared. What that means is I can cross-reduce out my a. So I didn't forget to write down that a. I actually just reduced my fraction in one go. Okay, I broke my pattern, what I said, so I want to rewrite that because that was me expanding out. The part that changed, I still want to show in another color, so that's why I put it in blue. I still have my plus c, and I am good. Okay, I'm just going to go through now and get rid of that green arrow up top. And I accidentally erased some stuff. There we go. Okay, I'm going to get rid of the red on the bottom. And I'm going to get rid of that gold off on the right side because I don't really need that anymore. Okay, I'm going to do two things at once right now. I'm going to take a look at that orange, and I'm going to do what I said I wanted to do. I have a perfect square trinomial inside those brackets. And so what I'm going to do is I'm going to factor it. Take a look up at the very top right. I want my perfect square to be factored to be in vertex form. So if I factor that, well then I'm going to have... Now, I think that part should be obvious. But this is the part where I'm going to kind of poke fun a little bit. If you're looking at that trinomial on the inside of the brackets and saying, hey, I need two numbers that multiply to give b squared over 4a squared and add to give b over a, then we've put the blinders back on and we're not thinking. Can I get you to look back over at the green on the right? Remember, the way that we figure out what goes inside the brackets is to take half of the coefficient on x. You'll notice we already did that in the green. So I've already done all of that work. I don't need to include that again. Rather, I know that that's going to be b over 2a on the inside of my brackets. There, I've factored my perfect square trinomial. Now, on the right side, if I can draw to your attention all of this stuff at the end, we're going to skip a couple steps here. I need to collect that into one term. Notice we have the blue fraction and we got to add on a c. That means I'm going to need a common denominator. Well, I can get my common denominator by multiplying c by 4a. Oops, I forgot my squared. I could go and put that together. However, you'll notice that my numerator is in a bad form. I have this negative term written first, then a positive term. I can actually simplify that by switching the order that I write those. So I'm going to skip some work, and we're going to do all of that in one go. I'm going to now write in my 4ac minus b squared all over 4a. There is my vertex form. Okay, I'm going to erase all the stuff that we should not need to be focused in on. That means the green is gone as well. And there is my vertex form. You'll notice that is y equals a times x minus h all squared plus k. It's just that each of those expressions are a lot uglier. Okay, what does that mean? Well, it means that's my h, that's my k. Okay, I want us to take a lot away from this, but I'm going to kind of focus it for you. If I was to look at that last orange line, I could now state that my vertex is negative b over 2a, comma, the 4ac minus b squared all over 4. I intentionally wrote it sloppy because I couldn't care. But that would be my vertex. If I don't care about it, you shouldn't care about it. I'm going to put a question mark as in a who cares. I do care about the x-coordinate of my vertex, though. What you'll notice is, for this generic quadratic function, y equals ax squared plus bx plus c, I just found out I always know what the x-coordinate of my vertex is. It's always negative b over 2a. That becomes an extremely useful property for me. Extremely useful. And that's what I want you to focus in on. We now have a means to go through and address changing a standard form into vertex form. I just want to add one thing into our note, that this process here of what I've highlighted in my green brace bracket is something called completing the square. And you can maybe see why it has that name, because we had to go through that process of figuring out how to make it a perfect square. Okay, biggest thing I want to put on you. Do not try to memorize that orange. We're going to talk about completing the square in class, and there'll be some times where I will go through that process, but you are not responsible for memorizing that orange process. Don't. It is not worth your time. It is worth your time to remember that the x-coordinate of your vertex is always negative b over 2a. Okay, that was a big, big process for us. I want to jump back into some doing stuff. See how this stuff is useful. Okay, you will see our instruction now on the screen, and this is our instruction for the rest of the lesson. What we want to do is go through and convert this to vertex form. So you will notice that the equation of the function I gave you was in standard form. Instead, we want to write it in vertex form. Now, I am not going to ask you to go through and complete the square on this. I'm not. But I'm going to. So I'm going to do this relatively quickly. If I had to complete the square, I would factor out that 2 from both terms that contain the variable. I could now figure out what value I would need to sub in to make that a perfect square. Well, if I take half of negative 8, that's negative 4, square it is a 16. I got to subtract out the 16 to make sure that what I'm adding in is 0. Now I need to expand that 2 with my negative 16 to get it outside the brackets. Now I can factor and simplify on the end. There I'm in vertex form. Please do not worry about scribbling that down. I'm going to go through completing the square in great detail. So don't worry about that for now. What I want you to focus in on, look at your vertex. Can you see that it's at 4, negative 7? Okay. Instead, I want to go through using what we know now about our negative b over 2a. So what I'm going to do is I'm going to get rid of all that gold. And I'm going to walk through another process. So what I'm going to do is I'm going to actually ask you to write down some information that might not seem that important right now, but it's going to become extremely useful. I want to talk a little bit about this as a parabola. I hope that we are good that because it has an a value of 2, we can see that we have a parabola opening up. And because it's opening up, we can see that there is a minimum to that function. So what I'm going to ask you to do is to make a note and explain that in your writing. For our minimum value, we now know that our x has to equal negative b over 2a, because we know that all max or min values occur at the vertex. Well, I could now sub in my a, b, and c. remember, my A value is 2, my B value is negative 16, my C value is 25. So I could now say, take the negative of my B value, which would switch that to a positive 16, all over 2 times 2, there's my 4, there's 4. I just found the x-coordinate of my vertex. And maybe you can make a note, things match up. Well, now what I can do, or what I need to do, is to find the y-coordinate of my vertex. So what I'm going to do is I am now going to sub my x equals 4 back into my function. When I do that, I'm going to get my 2 times 4 squared, which is 16, minus 16 times 4 plus 25. And that is going to give me 32 minus 64 plus 25. And if I take my 32 minus 64, well, that's a negative 32. Add on 25, there is my negative 7. I did all my work. The only thing I need to do, actually write it in vertex form. And so I have my vertex at 4, negative 7. And all I need to do is make sure that my parabola has the correct shape. Plug in my A value of 2. And there we go. Hopefully, you notice we match up with what we did before. Okay, that is a process that I want you to get really, really good at. And I mean really good at. There is also another facet to what I want to address with us using our negative b over 2a. This is something that can be used as a significant check. Okay, let's take a look back a little deeper. I just put up back on the screen our standard form versus vertex form, and I put down a couple key features. Remember our standard form in red, our vertex form in green. And then what I put down in blue was what we just found by completing the square on our generic function. That we have a times x plus b over 2a all squared plus question mark, because again, we don't care about the question mark. That told me that the x-coordinate of my vertex was negative b over 2a. Now you can see my orange arrow. What I'm going to do is I'm going to go back and I'm going to sub in negative b over 2a into my standard form. Okay, no problem if you are asking yourself, why are you doing this? Don't worry, but I want you to see what the outcome is. So if I now take negative b over 2a and I sub it in everywhere for my x, well, I'm going to square it in my first term. I now need to take my b, sub in my negative b over 2a. There we go. Okay, now I want to simplify. So when I simplify, we should be good that I can cross-reduce my a on my first term. And that gets me to b squared over 4a minus b squared over 2a plus c. Now, I want to stop there for a moment, because for some of you, you will be able to see something that will always occur right on that orange line. Look at your first two terms, b squared over 4a, b squared over 2a. And you should notice something very important. My second term, I divide by a 2. My first term, I divide by a 4. That means I'm dividing by an extra factor of 2. What that means is my first term is always half my second term. Always. Look at my numerators. They're exactly the same, b squared and b squared. That can be used as a check. My first term is half my second term. Now, Maybe you like it the other way. If I'm dividing my first term by 4 and my second term by 2, then my second term is double my first term. So it's 2 times my first term. It's double it. Okay, that might not be so obvious to see. I'm going to put in one more line. I'm going to get my common denominator between the first 2 terms. That means I don't have to change my first term. My next fraction I would have to double. So if I multiply my bottom by 2, I need to multiply my top by 2. And now maybe you can really see that relationship. My first term is half my second term because it doesn't have the times by 2. Or my second term is double my first because I can see the times by 2. That is a huge check. Okay, the other part that I want to make sure we're good on, your first and your second terms. They're different signs. The first term and the second term are opposite signs. Okay, if I can use that as a check, then I can know whether I've made my calculations correct. I'm not saying you fully understand what I'm talking about right now when I put up that. I want to jump back to problem A so we can look at it specifically. Here was that solution again. This is me going through and producing my solution. For my minimum, my x was negative b over 2a. I calculated my x value of 4. I subbed in 4. Here is where I can use my check. Notice, my first term is 32. My second term is negative 64. So first, let's look at the signs. They're opposite signs. One's positive, one's negative. The second thing, my first term is half my second. So I know I'm right. Or my second term is double my first. So I know I'm right. I know that I found the correct x value for my vertex, and I've subbed it in correctly. I know I haven't made any mechanical mistakes because that relationship is true. If I were you, I would use that as a check over and over again. That is very useful, especially given the opportunity for silly mechanical mistakes. Okay, I am hoping that that made sense for us, the ability for that check. Now I want to jump back into problem 1, and I want to get good again at going through and dealing with some mechanics. So let's take a look at B. I want to walk through one more time together how we can construct a solution to change that standard form into vertex. So the first thing I'm going to do, look at my direction of opening. I notice that I am opening up. And if I'm opening up, then I have a bottom. So therefore, I have a minimum. For my minimum, my x equals. Now, if you want to write down your negative b over 2a, feel free. If you just want to sub your values in, feel free. If I were you, I would get really, really used to writing it down until it's drilled in, then just using it. Switch the sign on your b value, divided by 2 times your a value. Now we can simplify that. I now know the x value of my vertex. So, like anything, I now need to sub in my x to get my y. So I'm going to sub x equals negative 3 into my function. My advice to you on your work, actually, let me just change that back to blue. Calculate your first term. Calculate the power. So square it. Sub in x in your middle term. Here is your opportunity to check. Notice your first term is half your second, and they're opposite signs. You know you are correct. Nice. So calculate. Well, 9 minus 18 has to give me the same number again because it was half. So it's 9, negative 9. Subtract one more is negative 10. The only thing that you have to do now is write it in vertex form. So put in your vertex and make sure that we have the correct shape. Your shape is normal. It has an a value of 1. Make sure your new function has an a value of 1. And there we go. And hopefully we match up. There you go. Okay, obviously those have some simple numbers to work with, and our numbers could get uglier. That should not hurt you. Okay, I would like you to try to work your way through C and try to come up with a vertex form for that parabola. Okay, try it on your own. Pause the video now. Okay, we're back. So I'm just going to put a little wavy line down. Here we go. So my parabola is opening up, so I know that I have a minimum. I know my minimum occurs at negative b over 2a for an x value. So I could sub in, switch the sign on the 5, divide it by 2 times 1. Ugh, I get a fraction. It doesn't reduce. That's okay. Now what I need to do is I need to sub my x value of negative 5 halves back in to my function. My advice to you before, simplify. There is my negative 5 halves squared. I'm now going to go through and sub in. Okay, I need a little bit of calculating to do. Now, because this is a fraction, some of us might not feel as comfortable to use that check. Look at what we did when we back proved this. Take one more step and now get your common denominator of 4. Well, that means I don't have to change my first term. But when I go to change my middle term, if I have to multiply that by 2, so multiply that by 2, you're now going to see that that middle term becomes a 50, and that should scream at you that you are correct. I've got 25 and 50. First term's half the second, or second's double the first, and they're different signs. I know I'm correct. The biggest mistake a lot of people will make here is that they're going to go ahead and they're going to write in a -8 on the end. Don't forget to get a common denominator with that 8 as well. So that means that I'm going to have a -32 there. Okay, go ahead and clean everything up. 25 minus 50 is -25. Subtract off 32 more gets me to -57/4. And there we go. Only thing left to do, write it in vertex form. So therefore, my y equals, put in your shape, well, shape of 1, normal, put in your vertex. And a nice, ugly vertex. And there we go. So hopefully that matches up with us, and we are good, and we were able to work our way through. Okay, I want to tackle a couple more of these just to make sure that we can get really comfortable with our process. Okay, you can see that our values are getting a little uglier as we go. Our numbers are getting a little bit bigger maybe. I think we are good to try each of these on our own. Okay? I want you to pause the video and give D a shot. Pause it now. Okay, we're back. So, I notice that I have a negative a value. That means my parabola is opening down, which means I have, a maximum. So for my max, I know that my x has to switch the sign on the 9 divided by 2 times my a. Now, I can reduce that fraction, and I really hope that you did, and you reduced it to 3 halves. So now I can sub an x value of 3 halves back into my function. I'm going to leave my coefficient out and simplify my power. Square the 3, square the 4. And do the same thing as I keep moving along. That means now I have my 9, I'm subbing in my 3 halves, and my minus 12. Okay, I can keep going with what I've got. Now, that's going to give me a negative 27 fourths plus a 27 halves minus 12. I'm going to shrink that down just to give myself a little bit more room. I get a common denominator of fourths. When I double my 27 with my common denominator, there is my check that tells me I'm correct. And now I can clean it up. On top, negative 27 plus 54 gives me a positive 27. 27 minus 48 gets me to negative 21 fourths. Make sure I write that in vertex form. So, put the correct shape on. Do not forget about your A value. And sub in your vertex, and you should be good. I'm going to shrink that down so we can see the whole solution. And we want that to become as automatic as possible. Okay, hopefully that one went well. And we're feeling more comfortable to jump in and play around with E. Okay, I want you to jump in on E. Pause the video now. Okay, we're back. So we should be good to go through that same process. I'm just going to make that a little bigger. I notice that I have a minimum. That's when I switch the sign on my B over 2 times my A. Well, because that was given to me in decimal form, I might end up working with decimals. I just really hope that we reduce that. Keep in mind, that's 3 over a half. And to divide fractions, I'm going to flip and multiply. That's 6. I would really hope that we subbed in an x value of 6 as opposed to 3 over 0.5. Okay, I can now sub x equals 6 back into my function. I'm actually going to switch that 1/4, that 0.25, back into a fraction because it might make my life a little easier here. Calculate all my powers, make my substitution into my middle term. 1/4 times 36 is 9. I see that I meet my property on my first and second term. That gets me to negative 7. So write that in vertex form. Hey, that one wasn't too bad. Put in your A value. I don't care whether you give me a decimal or a fraction as long as you're perfect. And hopefully we match up. So, as I said earlier, I'm hoping that this is feeling more and more comfortable. I want to give you one more to play with. And hopefully this one you can work through with great confidence. There's your last one for today. I want you to play through on F, and we'll see how we do when we match up. Okay, pause the video now. Okay, we're back. I'm hoping that it went fairly well. I want to work my way through relatively quickly, but I want to talk to you a little bit about some simplifying. So we notice that we're opening down, so we have a maximum. That means my x value has to be, switch the sign on the 3, over 2 times my A value. There's my negative 4. Okay, that's a bad form. We should be good to sub in negative 3/4. So I'm now going to sub in my negative 3/4 back into my function. Leave my coefficient, square my power. I can calculate my next one. Watch out on your sign. Okay, I'm about to get my check. Here's the issue though. I do not want to go and simplify that first term to negative 18/16 because now I'm going to have to get a common denominator of 16ths, and I don't like that. I hope you recognize that 18/16 reduces. And in fact, you can see it up in the blue. If I cross-reduce, I can work with smaller common denominators. That can be a really useful thing. So when I do simplify this, I'm going to get -9/8 plus 9/4 minus 10. As our last one, I'm going to sneak up onto the right. When I now get my common denominator of 8ths, the nice part is I don't even have to change my first fraction. Now I double my next one. There's my confirmation that I am correct. Common denominator with the 10. And now that whole thing, -9 plus 9, or plus 18, is a positive 9. Subtract off 80 is a -71/8. Okay, I did all the legwork. Now I just need to make sure that I write my function in vertex form. That was the instruction. Have the correct shape. I now have my x coordinate on my vertex and my y. Okay, your job, jump in and get really, really good at that process. When you are doing your practice, don't get sloppy with stuff. Make sure you have your statements for max, for min. Make sure you have your gold sub x equals statement in there. If you are doing all of those solutions with that proper form, then come evaluation day, you won't even have to think about duplicating it. It'll just be the way you do it. Okay, like always, your job, jump in and get some practice. Good luck.